Hello, everyone. Thank you for waiting. We just had some slight technical difficulties, but welcome to our joint webinar with TrustedSec, Deception and Discovery, How Attackers Hide Backdoor Accounts and How Defenders Find Them. Before we get started, a couple of housekeeping notes. This webinar is being recorded, and we will be sending out a recording of the presentation to everyone who registered. And we will be answering questions throughout the presentation and at the end of each section. So please feel free to type any of your questions into the questions section. And now a little bit about Binary Defense and TrustedSec before we jump in. Binary Defense is a managed security services provider and software developer with proprietary cybersecurity solutions that include SOC as a service, Forrester leading managed detection and response, security information and event management, threat hunting and counterintelligence. With our human-driven technology-assisted approach, we're able to provide clients with immediate protection and visibility, combating and stopping the next generation of attacks that businesses face. TrustedSec is an information security consulting team at the forefront of attack simulations with a focus on strategic risk management. The goal is to help organizations defend against threats of all kinds and change the security industry for the better. With a team handpicked not only for expertise and technical skill, but for ethical character and dedication, TrustedSec is committed to increasing the security posture of organizations around the world. Our speakers for today are Randy Pargman and Ben Mauch, and I will pass the presentation over to them.
Hey, good afternoon, everybody. Hopefully everyone is enjoying this wonderful Wednesday afternoon. My name is Ben Malk, but I'm going to go ahead and advance the slides here. Hopefully this works. And so my name is Ben Malk. I am the team lead for defense and countermeasures at TrustedSec. I have over 20 years of experience in cybersecurity. I spent 13 in defense and spent the last 7, 8 in offense. I've created other tools out there like that's not PowerShell, was one of the creators of NPS Payload, Honeycreds, and one of the primary developers on the Polar Bear project. I'll turn it over to Randy.
Good afternoon, everybody. My name is Randy Pargman. I am the head of threat hunting and counterintelligence at Binary Defense. I've been at Binary Defense for almost 2 years now, and before coming to Binary, I worked for the FBI for 15 years as a computer scientist investigating computer intrusions at different companies that had reported those to the FBI or the FBI notified them of. And I'm really happy to be presenting to you both from the attacker's point of view and the defender's point of view. I think working with TrustedSec, we get a lot of really great insight into techniques that attackers can use, and we're going to try to share with you both the attacker's technique and how you might be able to detect some of those techniques in your own environment. Back to you, Ben.
Yeah, and that's awesome. And that's one of the things that I think Randy and I are both of the same mind at, is that, knowledge is important. What we've seen, and Randy, I'm sure you've seen this too, what ends up happening and to the disadvantage of organizations is that you have defenders that really stand in that defender, workspace. And what ends up happening is that you're only looking at the defender component, which is great. And you definitely want to, expand your skill set in that area. But if you don't fully understand what it looks like from the offensive side, it limits you and you limit your capability. And what ends up happening is that you might build a defense around a specific TTP or a specific attack without fully understanding what the attacker is trying to do. And then you don't think ahead to think, how else might an attacker use to exploit this? And I think, Randy, I think you would agree that, knowing both sides really helps both offenders and offenders and pen testers to really expand in their skill set.
Yeah, I'd completely agree. In fact, I'd go farther to say that anybody who wants to be effective at defense must spend some time looking at the offensive side. You have to understand offense before you can even build a defense. Otherwise, you don't know what you're defending against.
Yeah, completely. So let's talk a little bit about hiding these backdoor accounts and basically what happened here. That we got onto this topic, and Randy and I we were talking about what are some cool little things and things that might prove some benefits. Well, obviously when an attacker gets on a system, it's one thing right now. You've got a lot of ransomware. We've got that big one that they just posted out there, $70 million to release everyone's data and stuff like that. And so like, it's one thing if they go into, just put ransomware, but even in that specific TTP, they sat on the accounts or on those systems for a while, and they had some persistence there. And so, me as being a penetration tester, but I'm also a defender as well. One of the things I was wondering is how could I potentially hide an account? And I was messing around the other day because, when we first started this, and we were building in a detection for when an account gets compromised or whatever the case may be. And one of the things we noticed was the machine account, which ends in a $, does a lot of the similar activity. And so what we were doing is we were excluding the machine account from our detections. And I thought, hey, I wonder, can I create an account that ends in a $, just out of grins and giggles? And so, I was sitting there messing around, and then I, decided like, hey, what might happen here? So, some of the things is, an attacker might want to get a foothold, that's on the system there. And why can't I move my mouse? They might get an initial foothold. They need that backdoor to get themselves in. How can I hide this, right? So if they can detect the account that was being added, is there a way that we can get around that? So that's my whole thing. I'll write detections, but I also want to know, can I get around my own detections? And, I've been doing this for years, and there are things that I've written today that I would not have been able to detect 5 years ago. And even though I wrote the detection. So we also want to see if one of the other things we want to do is figure out how we can hide something in plain sight. It's one thing to see the outliers or to catch things that specifically are outside of the norm, but what about things that blend in? And so that's what we're going to be covering today when we look at that. All right, so what happened is if you append a $sign to a user account with a net user command, you can actually hide it. I actually found out that you can actually just do this automatically. So I'm going to open up, I'm going to open this up here real quick. I'm going to make the font nice and big so that everyone at home can see. And we'll come over here. All right, so if I type net user, you can see all of the accounts that are on the system there. And typically you would do this for local accounts. Now, if you were to do this on a domain, it'd be a little bit different output here, but generally the idea is this lists the users that are on the account. If you want to add a user, you can actually do this from the command line. Now, we don't recommend that you do this just because the password is done in plain text, and if you're logging and to your SIM, the password will actually be in your SIM, which is not ideal. But just as an example, you could do TrustedSec and then open 24/7 and then add, right? And so if we do net user now, we can see we have our TrustedSec account. Pretty straightforward, whatever the case may be. But then I decided, I'm like, hey, could I do net user TrustedSec $? And I was just testing it out. I'm like, hey, oh, that's cool. And then if you do net user, I thought this was really neat, is that you don't see the $sign account that I just created. And I was like, oh, that's kind of neat. But then I was like, what happens if you just do this? And I'm like, surely this won't work. And it did. So I was really surprised that I could just add an account with a $sign. And so that led to this tweet that I posted out here. And I'm like, if you just do net user $sign, let me in, add active yes, you can log in with it. And so just to show you that you can actually log in with this account, if I come over here and say CME SMBU, and I'll just put my $sign in there, and the password is open 24/7 bang. Actually, let's put this in single quotes. And we'll say local authentication, and this IP is it 133? Yeah, 130. And as you can see, that account works. Okay, so this was me. This is saying I can log in with the $sign account, logged in successfully. Everything works great there. So I was like, oh, that's really neat. And so it hides it from the net user. But if you open up the local user manager, hold on, go back. If you look at the users, if I hit refresh on this, which is this button right here, you can see that I can actually see these accounts in here. So while it hides these accounts from that user, like you don't see my $ or TrustedSec, the local user accounts, it still showed up in. And so I'm like, oh, well, that's cool and all. And you can still see that, but I'm like, how can I hide it from here? Now, there was a reason I was trying to do some of the hiding in components and stuff was, so I kind of abandoned that project and then went on to something else. I went on to this other thing called a secure command shell. Now, this was part of the Polar Bear project, and Polar Bear stands for Path of Least Resistance. The Polar Bear project is a separate thing entirely, which is designed to give misinformation to an attacker if they were to land on a box, and also to inhibit their ability to do things like add persistence or to encrypt your files or whatever the case may be, while not necessarily impeding the user from doing so. And so what I did is in this application, what I did was just basically rewrote the entire secure command, or the entire command shell. And the idea was to get rid of things like echo and set and give it misinformation with whatever. But one of the primary components of this thing here is in the event that the command shell determines that it's running as an administrator, it'll actually create a new user with no privileges and then impersonate that user and then prevent it from doing any commands. And so so the idea was to do what's called a privilege de-escalation with this application. And so the idea here was to rehook the command shell on, and this would be typically done on a computer that's accessible by multiple people, maybe in a conference room or a kiosk or some point of sale system, whatever the case may be. So you'd want them that if they've got to this and someone tried to do like echo username, right? It wouldn't actually work. And so the idea was to give people the access to the command prompt without necessarily making it as easy for an attacker to compromise the system. I ultimately created this to keep my kids' computers safe. So that way I didn't have to worry about complicated things or whatever. I just replaced their command prompt with what this is right here. And then also to do the privilege de-escalation. And so you can kind of see that here, when you do who am I, echo hi, set L, those are the, whoa, I am not sure what just happened here. Okay, my screen got really small, but that's okay, we can still keep going. So one of the other things is in this screenshot, I'm not gonna do this here, but if you look, and I'll put this in the chat here in a minute with this link, it's an entire video where I show you that I go and I compromise a system that has the secure command enabled. And when I get a hold of it, you can see that once I've escalated, you can see I'm running as system. And then if I try and do any commands, it just basically gives me access denied. And so this is one of those situations to where, it was designed to be a security product just to kind of help people out, especially on those public access systems. Well, when doing that, I realized in some of my testing here, I realized that the code that I needed to add that new user could actually be used in multiple different ways. And so you can see I'm actually using the this API called net user add. And so I went in and just did a little bit of research on the net user add. And so that's really where all of this technique came from. So the idea here with the net user add is it adds a user to account and it assigns a password and a privilege level. And so looking at from the API specifics, now this is kind of technical, but basically it's just you give it a server name, what type of level, give it a buffer, and then a parameter error if you need it. None of those are really that important. What's really important is the level. Now what happens here is in the level you have multiple. We just use the user info 1, and so that's what that level is. You can pass it a name, you can pass a password, age, what type of privilege it has, set its home directory, set its comment, and then you can pass flags to it. The flags are what's really important here. So a lot of this, in the background, you have a lot of things that allows, like programmers and developers to add users. And so this is one of the ways they can do it. Now with the invention of PowerShell, this makes it, silly to have to go in and build your own, type definition here. But what's nice about this is that because we have access to this, we can actually change the account type. So come to find out that those flags, you actually can set up what's, a normal account, and that's usually what ends up happening. So in most of the cases when you're building an account, you're just building that normal account. You can also do it as a, if the account is in another domain, you can use temp duplicate account. If it's used for backup to another DC, you can do it as a server trust account. If it's an account that trusts other domains, you can do an interdomain trust account. But the one thing that really stuck out to me was computer account. It was a workstation trust account. And so I'm like, oh, I wonder if I change the flag from a normal account to this workstation trust account, what would happen? And so I'm like, let's just go test this out and kind of see what's going on. So let me show you. So as you can see, so this is the basic code, and I am not sure why my screen is doing this. Okay, so here's my net user add, and so all I'm doing is saying I want to use this as a flag. Okay, so I don't want this to be a generic, a regular account. I want this to be a computer account. I'm still going to add that $sign at the end because I want it to be hidden, right? And we'll get into these other examples here. We've got some homoglyphs and so forth and so on. And then I just used a built-in description here just to kind of share, make it look somewhat legit, but just more of a demo and everything that kind of goes from there. So if I open this up and I type get local user, all right, I'm gonna go ahead and remove all of these $signs. So let's say remove local user $sign. We'll say TrustedSec and TrustedSec $. Okay, so we're all nice and clean now. We don't have anything else going on here. If I look at my user manager and hit refresh on that, those are all gone, and we should be good to go. So let's go ahead and run this. And what this is going to do is it's going to create this TrustedSec $sign account with this let me in 123 bang as the password. So let's go ahead and hit run. There we go. So we can see that TrustedSec was added to administrators group. So let's come back over here and let's do a net user. Okay, so we don't have any TrustedSec $sign here. And let's look over here. Let's go ahead and hit refresh. There's no TrustedSec $sign here. However, if we look at administrators, you can see that we've got this account here. Now, I don't have to necessarily add it to administrators. Obviously, this is one of those things. Even if I remove this account, so if I remove it from administrators, okay, if I come back over here and I try with my, what did we say, TrustedSec $, and password is let me in 123 exclamation. This is going to be local authentication. Even though I won't say pwn, it's still going to show me that this is still a valid login. So I can log in with this account. It just doesn't show up anywhere. It's not showing up here. There's nothing here that shows up with this. However, this is where I will give Jeffrey Snover and the team over at Microsoft kudos. One thing I want to show you is even if we use get WMI object, if we do class is win32 user account. I think that's what it is. Okay, so if we look at this, even if I use the WMI for this, you'll notice I still don't see that TrustedSec dollar account. It's just not there. However, the get local user commandlet, it does show it. And so this is where I want to give kudos to Microsoft and everything else like that. For whatever reason, it's not showing up in any other thing except for get local user. So good job, Microsoft. Good job. Kudos to you guys. You actually pulled this one in, so this is really neat. And I know Randy's going to talk to you a little bit about the difference in being able to detect this from those two different components. But I wanted to show you a couple of other things that we kind of do this. Obviously, if we see TrustedSec dollar sign in there, it looks a little fishy. So because of that, I'm like, what other things could I do that may cause a defender to, maybe ignore it, right? So maybe that's what we're kind of looking for. So let's come back over here. And I've got a couple of other examples here. So this is actually, it looks like the word administrator, but it's not. In fact, this is a typical attack that they use in spear phishing campaigns, especially when they're trying to do links and that type of thing. So there's actually this really neat Homoglyph Generator out there. So it's created by Iron Geek. And what you can do is you just come over here and you type whatever you want. So if I typed administrator, right? And so what I can do now is he gives me a list of everything that might look like that letter A. And so I can come down here and choose any of the other A's. So if I click on this guy here, if I could click, there we go. So I can click on this A down here. I can click on this D. There's no real good M's and so forth and so on. But as you look down here, you can kind of see that one looks a little bit messed up, that D. What if I choose this D down here? There we go. And as you can see, it looks like administrator, but in reality, it's not. And so that's what we're trying to do. We're trying to come up with things that look similar to maybe get past some of your detection. Because honestly, adding administrator to the local administrator group, that's not necessarily that outside of the realm of possibility. And so, it's one of those things you're like, oh, well, administrator was added to local administrators. Well, that's okay, I guess. You know what I'm saying? And so that's one of those things where we're trying to create that persistence and still get around some of those detections. And so here we have administrator and adding to there. So if I go ahead and run this one, you can see when it prints up on the screen, you can see where my homoglyphs are. Okay, so you can see the D, the I, the O. And that's just because of the limitation of the console that we're using here. So this console obviously doesn't display a lot of the Unicode characters the way we'd like. However, even in like things like Splunk and QRadar and that type of thing, this comes in and it shows up nice. It doesn't show up as these question marks. And so we've tested this on Elk and Splunk and that type of thing. And trust me, these from a visual component, looking at it with your eyes, it looks the same. When you get into looking at like whether or not it's the correct character sequence, that's a different story. So let's go back and let's look at our local users. So if I hit refresh, okay, again, this is still my built-in account. There's nothing there, but if I look at the groups, well, now I've got 2 of them in here. And so that's one of those things where, like, unless you're actually going in and looking and seeing that there's 2 on there, just the event coming in of administrator being added to the local administrators group, that may or may not necessarily be something outside of the norm within your environment. Even when I do get local user, you can see that the D doesn't quite show up on this one, so maybe I could fix that a little bit. But as you can see, like the O and everything else, like they look pretty much the same. And so this is one of those things where, we're trying to get around some of those different detections and stuff like that. And so as you can see, if we can make this look similar or almost exact, but while still, accessing it, it works. And so just to show you as well, if I copy this and I go over here, because I can't type that character per se, and I'd say CME SMBU, and I go ahead and paste it. Okay, so there's that weird D, right? So you can see that there. Let me in, 1, 2, 3, bang, local auth, 172.16.133.130. There you go. And as you can see, when it comes up with this, that basically tells me that I'm local admin. And so there's me logging in with that weird D, the weird M, and I think this O is quite somewhat different there. So as you can see, just based on your terminal font, it might not render correctly, but in most situations when you're dealing with it getting over to your SIM, that's really where a lot of that evasion comes into play. So let me show you one other thing. This was one that I thought was really weird. If you type net view, okay, actually it's just net user or hostname, right? So here's my hostname. So my host name is NSA0XF, okay? Now, a lot of times what ends up happening is that when you look at your event logs and you look at some of the audits that go into play, if you're looking at things like 4624s, right? And we look at some of these things, let's see, I wanna see if we can have some that show, there's anonymous. Okay, so right here. So as you can see, here's my account name. You can see the account name in this authentication event is NSA0XF $. So that basically means that's a system account that's doing a lot of that activity. So in a lot of your SIMs and a lot of the things that are going on, a lot of people, when they build detections, they actually exclude some of these things from those detections. I wanted to see if I could take advantage of that. As I said in the beginning, I wanted to see what could happen if I added one. Well, not only can you add an account that ends in a $, you can actually add the host name. So if I type host name and say net user NSA0x, and I'll just do it all caps. Why you can do this, I don't know. Like, this doesn't make any sense to me. But you can actually just create an account with the host name ending in $. And so now any activity and things that go along, it's going to show up with that $. So if I come over here and I do CME SMBU NSA0XF $, let me in, 1, 2, 3, bang. This is again going to be local authentication to my Windows box. That worked just great. And if we look at our event log, you can see that I logged in with NSA0XF $. And so this is one of those things where, we would, one of the things to take in consideration when you're looking at some of the authentication events, I get it, some of these things may be spammy, but you have to be careful about just automatically excluding anything that ends in a $, because Windows natively will allow you to add those $signs at the end, and you can even add it as the machine name. And so this would easily go underneath a lot of people's radars, because they would see this authentication event and they're like, oh, well, that's just a system account doing something system-y, so I'm sure that's fine. Let's not take into account, let's just ignore the fact that it came from remote IP address, but you get the point, right? So there's a couple other things in here too. You can do emojis, you can do Unicode, and one of the other things too is you can also, one of the things I like to do is use a different language. Those are another ones that I like to use is, either use, Korean or Chinese, Japanese, or Russian, or something to that effect. In a lot of the characters, just by nature, when we deal with Windows, in a lot of situations, we default to the the English character set, right? Or I guess it would be the Roman character set, right? So just those basic things. And so you want to be careful about that, especially if you're an international company too. Something that you want to take consideration is those different characters that kind of go into all of those components. And so ultimately, when we're looking at something like this, you want to be careful a little bit about, automatically just, ignoring that $, and then also, looking at, the different ways that an account's been created. And so that's going to springboard into Randy's portion of this on how you can actually detect all of this. So Randy, I'm going to kick the presentation over to you, and then I'll let you kind of take it from here.
Thank you, Ben. I've been watching the questions coming in, and everybody was definitely in tune with what you were doing and connecting that with things that happen in their own environments, their own tools. I think one of the really important points is that, like you were showing, there's a lot of different ways to look at what are the current users on a system, and not all of those techniques work the same way. Some of them do not give the administrator, you, an accurate view of the state of the system, right? So not just assuming, not just trusting that your tools work as you think they do, but putting them to the test. And especially, when you see somebody who's doing threat research like Ben tweet something or put out an open source tool on GitHub, it's a great idea to go grab that tool and test it out in a lab. Especially if you're not quite sure how it works, you might not want to test it on your production systems, but test it out in a lab that you've got your detections set up on, and then see what that looks like in real life. So that's what we're going to do. We're going to take a look at some of the events that were generated, see if we can come up with some good detection techniques. I'm also going to share some software that I wrote and open sourced that can help with detecting the homoglyphs, which is really fun and interesting. Also very difficult because it uses optical character recognition, which is not 100% accurate, especially for some characters. But there's lots of different approaches that we're going to take, and we're going to jump right into that. Oops, there we go. See if I can actually control my PowerPoint presentation.
Okay. Randy, real quick, one person did ask if Do You See Me is available, and it is. I'm going to post that link here for everyone now.
All right, that's great. I am going to be switching back and forth between this and some other screens. First, let's look at what does it look like in the SIM when a normal user account is created. Normally, for user accounts, we get the event ID 4720 for a new user account created, and then there will immediately be a password reset, an enablement of that user account, and then the user is going to be added to a local group. And this is not assuming that the admin is deliberately trying to add the user like to the administrators group or anything else. This is just the local users group that a new user automatically gets added to, if that makes sense. So this sequence of events we should see every time we add a new user. So then let's compare that to what we got when we ran Ben's code from Do You See Me. So I took the open source Do You See Me that been published on GitHub. I compiled that, and I actually added some error checking to it and some more output so I could do multiple user accounts at once. And then I looked at what was the sequence of events that happened versus normal user creation and normal computer account creation. So first, let's actually look at when a normal computer account is created. This happens all the time as new computers are being added to a domain. But one of the first observations that I made is that normally in my Active Directory domain environment, when I add a computer account, which generates event ID 4741, that event is always generated on the domain controller. Even if I am a user adding a new computer to the domain for the first time and I'm doing it from that local workstation, the event ID 4741 is still generated on the domain controller. So that's detection criteria number one, is look for event ID 4741 that's generated on a workstation or somewhere else that you don't expect it. That's a really easy thing to detect as long as you know what your domain controllers are. The next thing that I saw was that when I created a new computer account the normal way, it was just 3 events. It was 4741 for the account being created. Believe it or not, computer accounts do have passwords, and normally when you create them, there is a password reset that is created. And then there's also a user account enabled. So 4741, 4724, and 4722. That's the normal flow of a computer account being created. when I ran Do You See Me, I've highlighted the things that are different in red. So hopefully that makes sense to you, but in case the red doesn't come out the way that you're looking at it, I just want to point out that we still got the 4741, difference being it was that event was generated on a local workstation, which was unusual. Then we got the 4724, nothing really unusual about that. And then we got a different event ID, 4742, which says computer account changed. That doesn't normally get generated when you're just adding a computer account the normal way. And then we still got the expected 4722, and then we also got something really unusual, and this should stand out. This makes sense that you would not normally see this. Event ID 4728, user added to global group. This is when that computer account was added to the local users group. Now think about it, that's something that you do not expect to see at all, right? Why would a computer account be added to the local users group? So that is your next detection criteria, something that you can key on, and if you see something like that, you should check it out and see what caused that. All right, here's the same thing on the left, same Do You See Me run, only instead of adding the NSA computer account, this time we're adding the homoglyph of administrator. But still, the same sequence of events gets generated. As you saw when Ben was editing the code live and recompiling and running, the only thing that he was changing was just the username, right? So you would expect to see the same sequence of events with the same tool being run. And you might also notice that administrator is being spell checked as incorrect because it has some homoglyph characters in there. It's not what we would expect to see for administrator. So on the right is the normal flow of a user account being created. The key things here are it's normally a 4720 event for a new user account being created versus a computer account being created, 4741. And then also, instead of, or in between the 4724 password reset and 4722 user account enabled, there is also this event ID 4742, which we saw in the screen just before this. And then the last thing that's different here is in a normal user account creation, when the user is added to the local users group, which is what we would expect for a user being added normally, that generates event ID 4732. But using the Do You See Me technique, that is still a user being added to a group, but it's a different event ID. It's 4728. So these are the differences that we can key on. And then let me switch, instead of doing the PowerPoint and screenshots, let's just take a look at some of these queries that we can run. So depending on what your SIM is, your query language is going to look different. This is using Azure Sentinel and Kuso query language, but you could definitely do this in Splunk or anything else that can query these event IDs. So the first query that I'm doing is looking for this unusual condition where the event ID is 4720. So in other words, a regular user account is being created, and the target username, that's the name of the account that's being added, ends with $. If you think back to what Ben just demonstrated when he was doing things on the command line and just added that username that was a $sign all by itself, that's what I did just a few minutes ago. I added that $sign only username, and this is how it showed up. So if you see anything like this or some other username ending in $sign and it's a user account, a 4720 event, that should set off some red flags and generate some alarms for you. The next query is looking at it the other way. What about a computer account that does not end in a $sign? And here we got the 4741 event, which is a new computer account being created. And I see that the target username, which is the name of the computer being added, is administrator. And in fact, this is the homoglyph of administrator. And you can see, just like Ben was mentioning in your SIM, like Splunk or Sentinel or whatever you're looking at, this really looks like administrator. You don't even notice something off. In this case, I'll tell you, the only character that is different is this I character, because I found that is the hardest one for people to spot. The D kind of stuck out to people sometimes. The O actually often is mistaken too. But in this experiment that I did, instead of replacing 3 characters, I just went for the minimal approach and tried to make it as sneaky as possible. And only this I right here is the thing that is different. All right, so these are really good queries, but there's also another set of queries that we can do that's a little bit more complicated. That's just looking at those sequence of events to see what is normal and what is abnormal. I've included this entire query for you in case you want to use it. You'll have that in the PowerPoint slides. So you don't need to try to madly screenshot it and remember everything that's going on, but let me just walk you through it really quickly. So I'm looking at 3 different scenarios. One is a computer account that was created and then added to a group. This would be the event ID 4741, and then that account being added to the local users group. The next scenario that I'm looking at is a computer account created, and then that change event that we saw that was unusual to do you see me and was not like a normal computer account creation sequence of events. And then the last one was the thing that I pointed out that should be really unusual is the computer account password reset and then added to a group. And that's when a computer account is added to the local users group. That should really stand out for you. So I ran this query just a little bit ago, and sure enough, it registered both of these, the administrator account being added and this computer account being added with the $sign at the end. So these are all really useful detection queries. And I would say that using those strategies that I just outlined is probably going to give you the most solid detections and the most reliable things with the least amount of false positives. But as a stretch goal, we really wanted to see how could we detect homoglyphs in general. And I don't know if you've seen the MITRE shield and the new detection techniques that are being propagated through that. But one of the things that it recommended specifically, not just for usernames, but for all kinds of events in your system, you should have the capability of detecting homoglyphs. So this is a piece of open source software that I've written, and this is available on the Binary Defense GitHub. You are welcome to grab that. Definitely appreciate any ideas to making this better, because as I said before, with optical character recognition, there's oftentimes mistakes. Just if you've ever scanned and OCR'd something, it doesn't always come out exactly right. So I tried to go about this a couple of different ways and produce some useful output. So you are also welcome to try this. This is live online if you go to glyph.binarydefense.com. It is HTTPS. And then you put in check, question mark, name equals, and then put in there the homoglyph that you'd like to check. And then for the other parameter, put in any other names that you want to compare it against. So in this case, I wrote administrator just with regular Latin characters. And then the output looks like this. So it gives you the other name, the existing name that you put in, and then the new name that you asked it to check. And as you can see, when you're looking at it just visually, these look exactly the same, right? But this Boolean output here says name is as it seems false. What this is telling you is that when the program took this name that you provided, this is the homoglyph name with the funny eye right there. That one is the thing that is strange. It rendered this text as an image, like a PNG, but it's just in memory. It's just pixels. So it just rendered that using an open source TrueType font that was from the GNU project, and it had pretty much the highest number of glyphs that I could find, so it could accommodate most of these things. And it's open source, which is a great bonus. And it then ran Tesseract to do optical character recognition on the rendered image. So now the computer is viewing the picture of the text just like you as a human would look at it. When the OCR is done, it should come up with something that does not have a funny character eye. Both of these eyes should be recognized as the same character, just the regular lowercase Latin character I that you're probably used to. What this came up with was when the program compared the OCR'd output to the original input, it said there's a difference. That's why it says name is as it seems false. So that's the first clue. The next thing that it gave you is the number of non-ASCII characters or non-Latin character set, and it highlighted this I, so it's telling you, hey, that one is the thing that is different. And then it's also giving you this homoglyph score 1, which means that this existing name that you passed in that you wanted to check against, administrator, that is 100% like the OCR of this funny name that you passed in. And this is how similar the OCR the name is to the original one. So it's about 92%, which makes sense. That's just one character off, right? So this is a way that you can have a computer help you with visualizing what is the difference and how different it is, and if a given string might be a homoglyph or not. As you can tell, it's very difficult for you with your eyes to tell the difference, but it's a little bit easier for the computer. Now, let me tell you where this has fallen apart so far is sometimes the OCR just doesn't work right, like a $ in the middle of a bunch of letters. It just thinks that that must be an S because it doesn't make sense to have a $ there. Or if you're using something like Korean characters or something like that, the OCR might not be all that great at detecting those. It does try, and it makes a best effort, but that might generate some false positives for you. So you need to keep that in mind. But how would we actually operationalize this? In my world, it is not good enough to have some great tool that an analyst could manually check things when they want to. We need to automate things. We need to operationalize things at large scale with hundreds of thousands of endpoints. So one of the things that I put together was a Microsoft Logic app. You could do this with any SIM. It doesn't need to be a Microsoft one, or you could use another SOAR tool like Tines or something else. Basically, all you need is something that can take the output of an alert that is generated in your SIM and then make an HTTP request to this glyph server, get the response back, parse the JSON, which is what we're looking at right here, and then just make a really simple logic decision. If the response indicates a homoglyph, then it goes through the true branch, and then we can just do something like change the title of the incident and make it a high priority, add a comment to the incident. So if we look at the output of that, here's the output of that logic app running against one of these incidents. So I actually have a number of different detection rules. This is the one that I was telling you before is probably the more solid one, where we're looking at that big query about the sequence of events to see if things are normal, if they make sense or not. And if not, it raises this alarm. But this is the one that is just generated on a new account being created, whether that's a computer account or a user account. Of course, you need to make sure that you're capturing those events, right? I mean, if your SIM is not capturing 4720 and 4741, you might be blind to this even happening. And assuming that you do, though, you can run it through, run the new username through an automation or SOAR framework like Logic Apps or something else. And then this took that result from the glyph server. And this is exactly what we were just looking at before, right? It's telling us that the OCR, the name was 92% like the name that you passed in. The comment tells us all of the details about, what we were looking at, and then it makes the recommendation that you might copy and paste this into something. I found if I just copy that username into something like Word or PowerPoint or something that lets you change the font, and I choose a font that is a stylized, something kind of script-like or something like that, or a font that has a lot of decoration on the letters, the glyphs, the unusual ones, the homoglyph characters, really stand out because they are not the characters that are being expected by that font. They're usually not rendered the same way. So if you're just having trouble seeing which characters are different, or you just want to check it, that is a super easy way to do a sanity check at the end. Just make sure you know what you're looking at and which characters are different. So that takes me through all of the detection criteria. I've not been looking at the questions, so let's see if there are questions that we can answer before we wrap it up.
Yeah, so really the only question is, why not use hashes instead of an OCR to detect the homoglyph?
Hashes as in like the MD5 hash of the username?
No. So like where you hash each character or something to that effect, right? So I think like having a dictionary of every possible, and I think, like what they're saying is instead of generating that OCR to look at each character individually, in that way. I'm assuming that's what they're trying to say.
Okay, let me take an idea off of that and see if this fits the question that was asked. But just before we started this presentation, Ben, you and I were talking about that Homoglyph generator on that website, and it's got already spelled out a list of common substitutions or substitutions for Latin characters that you might want to make. One of the ways to make the server work a little bit better, and I think I would just add this into it and still do the OCR and the rest of the stuff just because that's fun. But another way to do it would be to look at each character one by one in the new username and then just compare to see if that character is somewhere in the list of common substitutions. And then if there are any of those, bring those to the attention of the analyst who's looking at it and say, hey, this is a character that is commonly substituted for an A. If it looks like an A to you in the context, lowercase a, you need to know it's not, right? Like just highlight the characters that are not what they probably should be. It still is going to take a human to make the final decision and decide whether this was intentionally trying to be sneaky or this is just a regular username that happens to use those characters.
I think the beauty of this, and so we do this when we go through our purple teams. We look at a lot of these homoglyphs, and it's not as simple as, well, here's a list of all potentials, right? Especially if you're an international company. If you're an international company, and I kind of pointed this out during that demo, having a username with a non-Roman character is actually pretty high, right? And so you can't just say that just because it's using a non-ASCII character A through Z that it's now a potential homoglyph. So really, I think, and that's where the beauty comes in what Randy's trying to do with this OCR component is he's thinking ahead of the attacker, right? It's one thing to build a definition, but if there's let's say it's not really future-proof, if all of a sudden they add a different character or something to that effect, it may not necessarily be in your definition. It might not be in your data dictionary. And so really what he's doing is giving you the best ability when it's doing that OCR component. And yes, there's always going to be false positives, and it's, it's one of those things, but it's future ready. And in this way, you don't necessarily have to maintain that entire dictionary, right? So I think that's really where Randy's approach is kind of going from, from there. The second question, Randy, I guess you would be the better person to ask this. I know we haven't seen it here at TrustedSec, but have you guys seen the workstation trust account flag technique being used in the wild?
No, I have not seen that being used in the wild, but I also want to say that there are all different strategies being used to collect data, and something that is important for a lot of organizations is not collecting events that aren't really going to be useful. And in a lot of planning that I've seen, a lot of organizations have not wanted to collect the event ID 4741 because it doesn't seem like that really provided a lot of useful information. So if that is a good description of your organization, if that's something that you hadn't really thought about before, that's a really good idea to make that a priority. It's not a really noisy event. New user or new computer accounts don't get created at the rate of thousands a day in most organizations. So it's not a heavy lift. It's not gonna break the bank on your events per second. That just might be something that you just hadn't thought about before, because you hadn't seen somebody like Ben come up with a way to abuse it. So
well, I'll tell you, it's not in MITRE, so MITRE doesn't look at that, right? So it's not in the Windows for malware archaeology. If you haven't looked at the Windows logging cheat sheets, that's not recommended in there. And this is one of those situations where even I, a year ago, I wasn't recommending looking at 4741s. Randy, I don't even think you were even looking at 4741s from a binary defense perspective, or even during your FBI days. I don't even think that was even on your radar, right?
Nope, definitely not.
Yeah, and so this is just one of those things where, once you do this, making sure that auditing is set correctly is going to be one of those key components. And this is part of the reason that Randy and I wanted to team up and, share a lot of this information with you guys, because this is one of those events that not only, even if you are ingesting that 4741, chances are it's going to go undetected, but I would say most, if not all organizations are not even ingesting that log into their SIM right now. So that may be one of those things to go back and to evaluate. Another question here real quick is there a way to isolate names to a specific character set in a similar way we define password character parameters? So basically saying prevent user account creation and only allow these characters to be valid. And that's a question I don't know. I don't know about that from a Windows component, from a domain controller. Do you?
No, I'm pretty sure there is no way to do that. It's something that you're just going to have to detect it when it happens and raise alarms, and maybe you can automate like killing that account if it has some characters that you don't permit, and just beware of unintended consequences there. But I think that's something that you're going to have to automate the response to rather than prevention of.
Yeah, so and I think we've got one final question here. We are a little bit over, but it says, with the OCR solution, how are you getting programmatically the other names component from the log entry?
Yeah, so that is something that is left as an exercise to the reader. You can just have a list of usernames that you think are the most likely to be abused, the ones that you specifically want to compare against. But even if you don't have that list of other names, it'll still work all on its own just fine. So basically, if we just take this out, if you didn't have any other particular names that you wanted, you can still get the rest of the score just fine.
Well, great, awesome. Well, I think we're going to kick this back over to Emily.
Yeah, awesome. So thank you everyone for joining us for our webinar. And I did just want to repeat to let you guys know that we will be sending out a recording of the presentation and additional resources that have been discussed in the webinar today to you all via email within the next day or two. And if you have any further questions, Randy and Ben are both available. And I don't know if you guys want to kind of shout out where you're available, socials or anything.
Yeah, so I'm actually Ben10 or Ben0XA. You can do that on Twitter. You can also access that information through TrustedSec on the employee list page. So feel free to reach out in either of those ways. We're also on the or at least I'm on the TrustedSec Discord server, but I'm listed as memory dump on there.
Yep, and I'm also on the TrustedSec Discord server as Irish Death. I'm R. Pargman on Twitter, and you can also connect with me on LinkedIn.
Awesome. So with that, again, thank you all for joining us for our webinar today with TrustedSec, and we hope you have a wonderful rest of your day.
Awesome. Thanks, everyone. We'll talk to you guys later.
Thanks. Bye-bye.